Okay. All right, here's the review sheet that we have here, and we'll go ahead and start with problem number 1, where we're going to solve the equation, and it is a linear equation that we will solve for the variable. So in this case here we have 7 times the quantity, x minus 8, plus 18, is equal to 3 times the quantity, x minus 6. And here we're going to solve this linear equation for x. So basically all we're going to do here is just remove the parentheses and combine like terms on each side of this equation. That's the first step. So if I distribute the 7 over the x minus 8, I would get 7x minus 56. And then plus 18 on the left side. Then on the right side, I'll distribute the 3 over the x minus 6. I would get 3x minus 18. And then for each equation we will solve for the, well, each side will combine like terms here. So I'm going to bring down the 7x. And if I do negative 56 plus 18, I should get what? It's going to be a minus 38. And then that's equal to 3x minus 18. Now I need to get the variables on one side of the equation and the numerical terms on the other side of this equation. So it'd be best to move the 3x over to where the 7x is by subtracting 3x. So that means 7x minus 3x will be x minus 38, and that's equal to negative 18. Make sure you do bring down that negative sign in this problem. And then to get negative 4x, well, actually to get 4x by itself, we're subtracting 38, so we need to 38 and add 38. So that means 4x will be equal to, will be 20, right? And then get x by itself, finally divide by 4. So that means here x will be equal to 5. And if you do have the time, you can check your proposed solution if you wish. But do keep in mind there will be some problems where you will be required to check your proposed solution. So here x equals 5 is the solution to that linear equation. Questions about problem number 1? All right, number 2. Now here we have an equation that has fractions in them. So here we got x plus 8 divided by 5 minus x plus 4 divided by 2 is equal to 7 over 20. All right, now in this case here, we got a 5 and a 2 and a 20 in the denominators here. So that means we need to find an LCD, or the least common denominator, for 5 and for 2 and for 20. It would be 20. So the LCD there would be 20. So next I'm going to multiply each and every term in this equation by 20. So that means 20 will be multiplied by x plus 8 over 5, then minus 20 will be multiplied by x plus 4 over 2, and 20 will be multiplied by 7 over 20. Okay, and from here we just simplify by dividing in this term 5 into 20. That would go 4 times. So that means I'm going to have 4 times the quantity x plus 8 minus, then if I divide 2 into 20, that would go 10 times. So it'd be 10 times the quantity x plus 4. And then that's equal to, the 20s divide out, you'll be left with 7. So I have, this is what I have, 4 times the quantity x plus 8 minus 10 times the quantity x plus 4 is equal to 7. And now we can distribute on the left side. So if I distribute the 4 over the x plus 8, what would I get? X plus 32. And be careful here when you distribute the minus 10 over the x plus 4. What will you get here? Negative 10x and then minus 40. Then that's equal to 7. And now, combining like terms here, 4x minus 10x would be negative 6x. 32 minus 40 would be negative 8 or minus 8. And that's equal to 7. Now to get negative 6x by itself, I need to add 8. So that means negative 6x is equal to 15. Now if I divide both sides by negative 6, this will be negative 15 over 6, but negative 15 over 6 can be reduced to, okay, and it'll be negative 5 halves. So sometimes, when necessary, make sure that you give your answer in simplest form. Okay. Any questions about problem number 2? Yeah. This right here, that negative 15 over 6, negative 5 halves would be like negative 2.5 if you did that on a calculator. Numerator divided by the denominator. Okay? All right, any other questions? All right, number 3 is a rational equation with variables in the denominator. So here we got 6 over x plus 3, and then plus 2 is equal to negative 2x divided by x plus 3. Now on the exam, you're going to have like 2 parts to this rational equation. The first part is to identify the restricted value. That means what value of x will give you a 0 in the denominator. And then, keeping the restricted value in mind, you'll solve the equation. So the first thing we need to do here is get the restricted value. Now the only term that's in the denominator is your x plus 3. So we need to set x plus 3 to be equal to 0 and then solve for x. Now since x plus 3 is equal to 0, what must x have to be? Negative 3. That's your restricted value. That's the value of x that would give you this 0 in the denominator, and this will have a 0 in the denominator. Okay. All right, so next we'll solve this equation. Well, in this case here, the only thing in our denominator is the x plus 3, so the LCD here will be x plus 3. And then we're going to multiply each and every term in that equation by x plus 3. So that x plus 3 will be multiplied by 6 over x plus 3, and then plus, and I'll say 2 times, and put the x plus 3 here in parentheses, and then that's equal to, let's see, negative 2x over x plus 3. That's going to be multiplied by x plus 3. And now, when I simplify this, for this first part, the x plus 3's divide out, you're left with just 6, and then plus. I'm going to go ahead and distribute the 2 over the x plus 3. And what would I get there? 2x plus 6. And then that's equal to, here your x plus 3's divide out, you're left with a negative 2x. Okay. Now on the left side, if I add 6 plus 6, I would get what? 12. So it'll be 2x plus 12 equals negative 2x. And then next, what I'm going to go ahead and do here is take this 2x and move it over to where the negative 2x is. I'm going to do that by subtracting 2x. So that means I have 12 on this side, and that's equal to 2x minus 2x will be negative 4x. So negative 4x will be equal to 12. And then if I divide both sides by negative 4, I'm going to get x equal negative 3. Is x equal negative 3 my restricted value? Yes, it is. And when that happens, that means you have to exclude that restricted value. And by the way, if you were to check your proposed solution, you're going to find out that you're going to get a 0 here in this denominator and a 0 in this denominator as well. So that means that this rational equation has no solution. Now, I will warn you, don't expect to get an equation where the answer is going to be no solution. Okay, you might even get a solution that is different from your restricted value. Okay. Are there any questions about number 3? Okay, number 4 deals with a quadratic equation. And in this case, we got 3x squared minus 147 equal to 0. And we're solving this quadratic equation. And in this case here, you're told to use the square root property. Use the square root property. So in this case here, I need to get x squared by itself. And how will I do that? Add 147 on both sides. So that means I have 3x squared is equal to 147. And then to get x squared by itself, I need to divide by 3. So that means x squared is equal to 49. Now I want to solve for x. It's being squared, so what's the opposite of squaring something? Take its square root on both sides. And what do I need to include here? Plus or minus. Anytime you take the square root on both sides of an equation, you have to include plus or minus. So the square root of x squared will be x, and that's equal to plus or minus. Square root of 49 is 7. Now you can leave your answer like this as x equal plus or minus 7. Or you can write it like this. X equals 7 or x equal negative 7. Okay. Are there any questions about problem number 4? All right, problem number 5 deals with completing a square. And in this case here, we got x squared minus 2x minus 5 equal 0. And here we're going to solve this quadratic equation using the concept of completing a square. All right. Now, the first thing you need to do here is get all the terms that have the x's on one side and move that constant term over to the other side. So here I need to move the minus 5 over to the right-hand side of the equal sign. And I'm going to do that by adding 5. So that means I have x squared minus 2x is equal to 5. And now I'm going to complete the square. Now the way that we complete the square is this. We take 1/2 the coefficient of the x term and then square it. So I'm going to take 1/2 the coefficient of the x term, which is in this case -2, and then I'm going to square it. So if I take 1/2 of -2, what would I get? -1, and then if I square it, I'm going to get +1. So now I'm going to add the 1 to the left side and also to the right side. Whatever I do on one side, I have to do the same thing on the other side. So I'm adding 1 to both sides of this equation. The left side will be a perfect square trinomial, which is what completing the square does for us. It gives us a perfect square trinomial, x squared minus 2x plus 1. And this can be factored as the square of our binomial. We know we're going to have an x. And if I take 1/2 of -2, that's going to be -1. So it'd be x minus 1 quantity squared. And then that's equal to 5 plus 1, which is 6. All right, so now I can apply the square root property to solve this equation. The x minus 1 is being squared, so the opposite of squaring something would be to take the square root on both sides, include the plus or minus symbol, and then square root of 6. Now, if you take the square root of x minus 1 quantity squared, you're going to end up with just x minus 1, because the square root and the square are inverse operations. And that's equal to plus or minus the square root of 6. And now to solve for x, I'm subtracting 1. I need to add 1. So it'd be x is equal to 1 plus or minus the square root of 6. And you can leave your final answer like this, or you could write it like as two separate answers. X is equal to 1 plus the square root of 6, and then x equal 1 minus square root of 6. I'll put or in between those two, because that's what the plus or minus symbol means. All right, questions about problem number 5. All right, in problem number 6, you're going to solve the equation using the quadratic formula. This is something that you could put on your one-page sheet of notes here. All right, so here we got x squared minus 2x minus 5 equal to 0. All right, so as you can see here, that equation is written in general form, where the zeros on one side of the equation. Oh, come on now. Okay, thank you so much for correcting me. I must be fixated on something. X squared minus 13x plus 40 equals 0. So now you got a 0 on one side of the equation. Now we can identify A, B, and C. So here A is equal to the coefficient of the x squared term, which is 1. B, which is the coefficient of x, is negative 13. C is the constant term. That's 40. And then the quadratic formula, we start by writing what that is. X equal negative b plus or minus the square root of b squared minus 4ac divided by 2a. And then we substitute a, b, and c in the quadratic formula. Bring down the negative sign, replace the b with negative 13, so it'll be negative of negative 13 plus or minus the square root of b, which is negative 13, and that will be squared minus 4 times a, which is 1, times c, which is 40. Whole thing is divided by 2 times a, or 2 times 1. And then we simplify the whole thing. So here we're going to have x equal negative of negative 13 is 13, plus or minus the square root of negative 13, and you square it. That'd be negative 13 times negative 13, or 169, minus 4 times 1, which is 4 times 40, that's 160. All that's divided by 2 times 1, which is 2. Then from here, 169 minus 160 would be what? 9. So I have x equal 13 plus or minus the square root of 9 all over 2. And what is the square root of 9? Should get 3. So it'll be 13 plus or minus 3 over 2. Now, what this means is I can write this as 2 separate answers. Of course, this will be x equal 13 plus 3 over 2. And the other answer would be x equal 13 minus 3 over 2. So here for that first one, 13 plus 3, that would be 16. 16 divided by 2, 8. And then for the other, 13 minus 3 will be 10. Divided by 2 will be 5. So for this quadratic equation, these are my two solutions here, 8 and 5. All right. Are there any questions about problem number 6? All right, number 7 is solving a radical equation and check your proposed solutions. And I do specify on the exam that you are to check your proposed solution. That is, if you want to receive full credit for that problem. Not only do you solve the equation, you have to check your proposed solutions here. Here we got the square root of 10 minus 3x is equal to x. In this case here, we want to make sure that the radical is by itself, and in this case, it is. So now, what's the opposite of taking the square root? Squaring. We square both sides of this equation. when you square both sides on the left side, the square eliminates the radical. You'll be left, eliminates the square root, I should say. You're left with what's underneath it, 10 minus 3x equals x squared. So now we have a quadratic equation where we're going to need to get all the variables on one side, well, all the terms on one side, and a 0 on the other side. I'm going to leave the x squared on this side. I need to move 10 minus 3x over to the opposite side. How would I do that? I need to do minus 10 and add 3x. And when I do that, I'm going to get a 0 on this side, and then that's equal to, bring down the x squared, minus 3x minus 10. And that x squared minus 3x minus 10, I'm going to try to factor that into two binomials here. Let's see, the x squared, I can break that up as x and x. Factors, what would be factors of negative 10 that would give me negative 3x as a middle term? Should be, yeah. Yeah, plus 5 and a minus 2. 5 and 2 are the factors. The larger of the two factors takes the sign of the middle term. The middle term is the plus, the 5 has to be plus, and the 2 has to be minus. So the x plus 5 times x minus 2 is equal to 0. Then we set each binomial factor equal to 0. So this means x plus 5 equal to 0, or x minus 2 equal to 0. Each equation we're going to solve for x. So for the x plus 5 equals 0, if I subtract 5, that means x has to be equal to negative 5. Or for the x minus 2 is equal to 0. If I add 2, I'll get x equal 2. Those are my two proposed solutions, but only one of them is the actual solution for this radical equation. So this is where we check our proposed solutions. And I'm going to start with x equal negative 5. And using the original equation, I'm going to replace each x with negative 5. So I have the square root of 10 minus 3 times negative 5. I want to know if that's going to be equal to x, which is negative 5. Square root of 10 minus 3 times negative 5 would be plus 15. And I want to know if that's equal to negative 5. 10 plus 15 is 25, so the square root of 25, if I take the principal square root of 25, that would be positive 5. Does 5 equal negative 5? No. So that's a false statement. So that means that x equals negative 5. That's my extraneous solution. I can go ahead and cross that out. But to be on the safe side, I'll go ahead and check x equals 2. So this would be the square root of 10 minus 3 times 2. Now I want to know if that's equal to x, which is 2. And then square root of 10 minus 3 times 2, which is 6. And then 10 minus 6 will be 4. If I take the square root of 4, I get 2. Does 2 equal to 2? It does. So that means here x equals 2 is the solution to that radical equation. Are there any questions about problem number 7? Problem number 8. here we got x to the third plus 12x squared plus 35x equal 0. And I'm solving this polynomial equation. Well, to begin this problem, I need to factor it completely by finding a greatest common factor that's in x cubed, 12x squared, and 35x. Has to be just x. The x is common in all three terms. We take the one with the smallest exponent, so x would be your common factor. All right, so we're going to divide each term by that common factor of x, so x cubed divided by x squared. X cubed divided by x, I just gave that away, x squared, plus 12x divided by x. 12x plus 35x divided by x. 35. And that's equal to 0. Now I can factor the x squared plus 12x plus 35 into two binomials here. So here I got x and x for x squared. What factors of 35 would give me 12x as a middle term? 5 and 7. And they both have to be plus signs, because the middle term and the last term have plus signs in them. So I have x times x plus 5 times x plus 7 equal to 0. And each factor will be set equal to 0. So this means x is equal to 0, x plus 5 equal to 0, or x plus 7 equal to 0. And I'm using a zero product principle. Each equation will solve for x. So here x equals 0, that's already solved for x. But for x plus 5 equal to 0, what would x have to be equal to? Has to be equal to negative 5. And then for the x plus 7 equal to 0. 7. So here, these are the zeros of this function. X equals 0, x equals negative 5, x equals negative 7. And here it doesn't have to be in any particular order. All right, questions about problem number 8. All right, number 9 is a rational equation where the exponent is in the form of a fraction. So here we got 5x to the 3/2 power minus 40 is equal to 0. All right, now before I do anything, I need to check out that 3/2, which is my exponent here. It's going to tell me whether or not I need a plus or minus sign. And also it's going to tell me whether I need to check my proposed solution. The numerator tells me whether I need a plus or minus symbol. The 3 is even or odd? Odd. And since it's odd, that means I do not need a plus or minus symbol. Now, if it was even, I would. The denominator of 2, is it even or odd? This time it's even. If it's even, you have to check your proposed solution. If the denominator is odd, you do not check the proposed solution. So no, I'm not going to need a plus or minus symbol, but I will have to check that proposed solution. Now let's get the x to the 3/2 by itself. I'm going to start by adding 40 to both sides. So that means I'm going to have 5x to the 3/2 equaling to 40. Now to get x to the 3/2 by itself, I'm multiplying it by 5. I need to divide by 5. So the x to the 3/2 equals to 40 divided by 5, 8. Now, that exponent of 3/2, what would be the reciprocal of 3/2? 2 over 3. So I'm going to raise both sides of this equation to the power of 2/3. And this 8 would be to the 2/3 as well. So when you're raising both sides to the reciprocal power, on the left side, 3/2 times 2/3, you're raising a power to a power. When you multiply 3/2 times 2/3, that's going to be a 1. So it'll be x to the 1, or just x. And that's equal to, and I'll go ahead and write down 8 to the 2/3, which can be done in the calculator by doing this. You'll type in the 8, you'll press the hat key, and then 3 divided by 2, and press enter. And what did you, and if you did this on the calculator, what would you get? 4. And here it doesn't have the plus or minus, don't need the plus or minus symbol, so that means x equals 4 is our proposed solution. However, since the denominator that we started off with was even, we have to check our proposed solution. So I'll do the check over here. Using the original equation, I'm going to replace the x with 4. So it'll be 4 to the 3/2 minus 40 equal to 0. Now, of course, order of operations is this. You have to do your exponents first. You have to do 4 to the 3/2, which is what? It's going to be 8. And of course, in the calculator, you can just do the 4, the hat key, and then 3 divided by 2, and then press enter. You'll get 8. Minus 40 is equal to 0. And then 5 times 8 would be 40. And 40 from 40 does give us 0. So that checks. So that means here x equals 4 is the solution to that to that equation with rational exponents. All right, any questions on problem number 9? All right, number 10. This is where we use an appropriate substitution. Here we got x to the 4th plus 13x squared plus 36 equals 0. And if you have a handout, one of those review sheets that didn't have that, you just had this, it's supposed to be equal to 0 since it's a equation that we're solving using an appropriate substitution. All right, so the way we use an appropriate substitution is going to be this. You're going to let u equal to the variable of the middle term. Here's the middle term right here. That variable is x squared. So we're going to let u equal x squared. And then we're going to find out what u squared is. And to do that, I need to square both sides of this equation. So this will be u squared is equal to, here x squared raised to the power of 2 would be x to the 4th. Raise the power to a power, you multiply your exponents. And then we substitute into this equation in terms of u. So that means your x to the 4th, right here, that would be u squared. So this x to the 4th would be u squared plus 13 times that x squared, we're letting that be u. So it'll be 13u, and then plus 36 equal to 0. So now we have a quadratic equation in terms of u. Next step would be to factor this into two binomials here, if we can. So the u squared would be u and u. Factors of 36 that would give me 13u as the middle term would be 9 and 4. And I think I messed that problem up. That should be a minus sign. Yeah, yeah. Because we're going to have some problems here with if it doesn't come out right. That should be a minus sign. And they both have to be minus. So u minus 9 times u minus 4 is equal to 0. Yeah, it's supposed to be minus 13x squared. Now for each equation, we'll solve for u. So here for the u minus 9, that's going to be equal to 0. U minus 4 is equal to 0. And then for each equation, we'll solve for u. So for the u minus 9 equal to 0, if I add 9, you're going to get u is equal to 9. And then for the u minus 4 is equal to 0. That means u is equal to 4. Now you cannot end this problem in terms of u. It has to be in terms of x, since the original equation was in terms of x. So now this is where the back substitution comes in. Here we let u equal to x squared, so that u will be replaced with x squared. So here we got x squared is equal to 9, and then x squared is equal to 4. Okay. That's why this had to be a minus sign here, because I was going to get x squared equal negative 9 and x squared equal negative 4. Okay, so if I since x squared equals 9, I'm going to solve for x by taking the square root on both sides. Include the plus or minus symbol. That means x is equal to plus or minus 3. Or, I'm still going to take the square root on both sides on that x squared is equal to 4. Include the plus or minus symbol. That means x is equal to plus or minus 2. Okay, so here I have 4 solutions to this equation that's quadratic in form. 3, negative 3, 2, negative 2. Again, they don't have to be in any particular order. Are there any questions about problem number 10? All right, number 11 deals with an absolute value equation. Okay. So everyone have this. Okay. So here's number 11, absolute value equation. So here, the absolute value of 3x plus 5 minus 2 is equal to 6. And here I want to solve this absolute value equation here. First of all, I need to get the absolute value by itself. I'm subtracting 2, so I need to add 2 to both sides. So that means that the absolute value of 3x plus 5 is equal to 8. All right, so next step here, I need to go ahead and write my two equations since I'm dealing with an absolute value equation. The first equation will be 3x plus 5 equals to 8. Or the second equation, 3x plus 5 equals negative 8. And each equation will solve for x. So for the 3x plus 5 is equal to 8. If I subtract 5, you'll get 3x is equal to 3. Divide both sides by 3, you'll get x is equal to 1. Or for the 3x plus 5 equal negative 8, now if I subtract 5, this time 3x would be equal to 13. Divide both sides by 3. X will be equal to, and I'll leave this as an improper fraction, negative 13 over 3. So that means my solution set here will be just 1 and negative 13 thirds. All right, questions on number 11. All right, number 12 is a inequality. Now, it says here solve the inequality and graph the solution set on a number line, and then write the solution set in interval notation. So you got three things going on here. You have to solve this inequality, which is 3 times the quantity x plus 7 minus 12 is less than 5x plus 1. Then you have to graph the solution set on the number line and give the answer in interval notation. So in this case here, I need to remove the parentheses and combine like terms. So in this case, if I distribute the 3 over the x plus 7, what would I get? Plus 21, and then minus 12 is less than, bring down the 5x plus 1. And then if I do 21 minus 12, that's going to be 9. So I had 3x plus 9 is less than 5x plus 1. Now, preferably, I would like to move the variable on the left-hand side of this inequality. So I'm going to move the 5x over to where the 3x is by subtracting 5x. And now 3x minus 5x will be 2x plus 9 is less than 1. And then get negative 2x by itself by subtracting 9. That would mean negative 2x is less than negative 8. And then when I divide both sides of this inequality by negative 2, what's going to happen to that less than symbol? We're going to flip it from less than to greater than. So the x is greater than 4. That's the solution set for this inequality. Now we need to graph this solution set on a number line. And by the way, you will have number lines provided on the exam. So here's 4. Well, I need a bracket or parentheses. Parentheses, because it's strictly greater than. Okay, so I'm going to need a left parentheses at 4. The greater than symbol points to the right, so that tells me I need to shade to the right of 4, like this. And then identify that solution set in interval notation. So in this case here, the 4 has the left parentheses, so it'll be 4. This goes indefinitely to the right, so it'll be from 4 to infinity. And it's an open interval 4 to infinity. All right, any questions about problem number 12? All right, in problem number 13, we have a compound inequality where we're going to solve and graph the solution set on a number line and then write that solution set in interval notation. So number 13, we got -2 is less than or equal to 3x plus 4, 6. And in this case here, we're going to solve this inequality. And it's a compound inequality, so we need to isolate the variable in the middle by performing the same operations on the left side, the middle, and the right side. So to get this x by itself, I need to start this off by doing what? Subtracting 4. I'm adding 4, so the opposite would be subtract 4 on the left side, subtract 4 in the middle, subtract 4 on the right side. So here this will be -2 minus 4, -6, less than or equal to 3x, and less than 6 minus 4, which is 2. And now to get x by itself, I'm multiplying it by 3, so I need to divide the left side, divide the middle, and divide the right side by 3. And when I do that, -6 divided by 3 will be -2, less than or equal to x, and less than 2/3. So this is my solution set for this compound inequality. -2 is less than or equal to x and less than 2/3. Next, I'm going to graph the solution set on a number line. Let's see, put 1 here, -1, -2. For -2, would I need a bracket or parentheses? Bracket, because that's less than or equal to, that means -2 is included. Now for 2/3, which is a little bit less than 1, I'm going to put 2/3 about right here. Do I need a bracket or parentheses? This time parentheses at 2/3. And to indicate that all the values of x are in between -2 and positive 2/3, I need to shade in between. So now I have a half open, half closed interval. And it's going to look like this. At -2, I have a left bracket. At 2/3, I need a right parentheses. So that would be your interval notation for this problem. Any questions about problem number 13? All right, problem number 14 deals with absolute value inequalities. Well, both 14 and 15 are absolute value inequalities. So here, number 14, we have the absolute value of 3x minus 1 is greater than or equal to 5. Now, as you recall back in section 1.7, I gave y'all 2 cases for absolute value inequalities. You have to look at you want to make sure that the absolute value symbol is by itself, and also your inequality symbol will tell you how to set up your 2 set up your inequality. But this one right here is greater than or equal to. And I'll go ahead and tell you right now, with greater than or equal to, you'll have to write two separate inequalities here. Two separate inequalities. One of them would be this. 3x minus 1 is greater than or equal to 5. Or, for the second one, 3x minus 1 is less than or equal to negative 5. That second inequality, you switch your inequality symbol to the other direction, change the sign of your constant term from positive to negative. All right, each inequality will get x by itself. So starting with the 3x minus 1 is greater than or equal to 5, we need to. So here's going to be 3x is greater than or equal to 5 plus 1, which is 6. 6. So for 3x is greater than or equal to 6, if I divide both sides by 3, that means x is greater than or equal to 2. Now for the 3x minus 1 is less than or equal to 5, I need to, still add 1. But now 3x is less than or equal to, this time, negative 4. And then sides by 3. This will mean x is less than or equal to, and I'll leave this as negative 4/3. That would be the solution set. X is greater than or equal to 2, or x is less than or equal to negative. All right, and now I'm going to graph the solution set on a number line. And negative 4/3 is like negative 1 1/3. I know I'll put that about right here. Let's start with the x is greater than 2, greater than or equal to 2. But I need brackets or parentheses. Brackets, because we're including the 2. So I'm going to use a left bracket at 2. That greater than symbol points to the right, so that means I need to shade to the right, like this. Now for x is less than or equal to negative 4/3. Again, a bracket, this time at negative 4/3. And this time the less than or equal to symbol points to the left. We shade to the left. So your graph is going to look like this, going in opposite directions. The interval notation is different because you're going to go from left to right reading this graph. This is from negative infinity up to negative 4/3. And negative 4/3 is included, so we use a right bracket there. We use this symbol for the union of the two. The 2 has a left bracket, and this goes indefinitely to the right, so that means we use infinity. And that is what your interval notation looks like, from negative infinity to negative 4/3, or from 2 to infinity. Questions on problem number 14. And finally, number 15. Here we got absolute value of 7x minus 5 is less than 9. And again, we're going to solve and graph the solution set on a number line and write that solution set in interval notation. So in this case here, this time, our inequality symbol is less than, and we do have the absolute value by itself here. But for less than, we write this as a compound inequality. So the setup would be this. That's 7x minus 5, which is inside the absolute value. That goes in the center of your two less than symbols. The 9 on the left side will be negative. The 9 on the right side will be positive. Okay. Now, let's go ahead and isolate the variable by itself in the middle. We're subtracting 5. I need to add 5 on the left side, add 5 on the right side, and in the middle. All right, so negative 9 plus 5, negative 4, that's less than 7x, and less than 9 plus 5 is 14. Now to get x by itself, I'm multiplying by 7. I need to divide the left side, divide the middle, and the right side by 7. So I'm going to leave this as negative 4/7. That's less than x, and less than 14 divided by 7 will be 2. So this is my solution set for this compound, for this absolute value inequality. Negative 4/7 is less than x and less than 2. So with an absolute value that's less than or less than or equal to, you have to write that as a compound inequality. Now here's the solution set on a number line. Let's see, negative 4/7 is less than negative 1. So I'm going to put it about right here. Well, I need brackets or parentheses. Parentheses on both of them because they're both strictly less than. So here, a left parentheses at negative 4/7 and a right parentheses at 2 to show that x is in between negative 4/7 and 2. We're going to shade in between. So that's what the graph looks like. Now for the interval notation, left parentheses for negative 4/7, comma, 2 right parentheses. So that would be your interval notation for that solution set. All right, questions on number 15.